My name is Rajneesh Singh, and I'm the author of Module 4 of the Academy of ICT Essentials for Government Leaders, where we will be looking at ICT trends for government leaders. In just a short few decades, the use of information technology systems has completely transformed how we live, work and play. New markets and new business models have emerged to support the entry, storage, processing, analysis and presentation of information, and these are continuing to evolve and advance at a rapid pace. Global stock markets are now driven by trading technology-based companies as much as commodity and traditional industries. And information technology is continually being looked at in new ways as a means to deliver improvements in socio-economic conditions and as a tool for achieving the Millennium Development Goals, or the MDGs as we call them. So where did all these technological developments come from and where are they headed? In this module, we will try and answer this question and provide some insights into current trends in information and communications technology, or ICT as we commonly refer to them as, and its future directions. It will also look at some of the key technical and policy considerations when making decisions for ICT development in the local and regional context. Now, in terms of the module objectives, the module itself aims to provide an overview of the evolution of ICT and the role it plays in today's dynamic global environment. It will describe current and emerging technologies and their impact, and it will describe the key components of ICT infrastructure and the associated policy and technical considerations that one must make. In terms of the learning outcomes, after going through this module, we expect that you should be able to describe the current and emerging technologies and their impact, describe the critical components of ICT infrastructure, identify some key policy and implementation considerations in making effective ICT infrastructure development decisions at the local and national level, and you should be able to describe the status of ICT infrastructure, projects and programs in terms of current technological developments and trends, and in terms of the relevant policy issues. This first session will look at technological evolution, and in particular broad developments around it which have shaped it. We will describe some key technological developments that have shaped today's information technology landscape. We will discuss the issue of the digital divide and some methods to measure it from an access and infrastructure perspective. We will provide a basis for discussion in defining access to information and communication technologies, and we will then outline some policy considerations that are relevant to national ICT planning. A quick succession of technology breakthroughs has revolutionized how we communicate and exchange information. Probably the first major breakthrough was the invention of Morse code in 1837, which allowed the conversion of physical movement into electrical impulses that could travel long distances. This was followed by the setting up of an experimental telegraph line in 1844 to transmit data between Washington, D.C. and Baltimore, Maryland in the USA. By 1858, the first telegraph lines had been laid across the Atlantic, setting the stage for what we call international communications. In 1875, Alexander Graham Bell invented the telephone, and thus began a new era in personal communication. The era between 1910 and 1920 brought AM radio stations, and by the 1940s, television was available, broadcasting sound together with images, which is quite an evolution in itself. The first electronic computer was created in 1943, and with the invention of the microprocessor in the 1970s, affordable computing for the masses was slowly beginning to show promise. The 1980s introduced the personal computer to the general public. IBM launched what was then called the IBM PC, and still is today, in the USA in 1981, and subsequently in other regions of the world. While other companies were offering PC products, IBM's offering was based on open standards, the first of its kind on the market. Most of these PC products had similar operating systems, which meant that users were able to interact with each other through the sharing of data and applications. The 1990s saw desktop computing gain momentum, with rapid advances in technology and processing power, and a reduction in prices. This was also the era of the internet entering the mainstream, moving into the corporate world and into people's homes, and of course rapidly becoming the emblem of the information age as we know it today. The creation of the World Wide Web was a catalyst in the move from research to mass acceptance, and today the internet and its related technological drive and its related technologies drive businesses and economies globally. But the evolution has not stopped there. The internet is making possible new ways of doing things, and in particular doing new ways of doing things that we used to do previously. The use of the internet to send and receive voice communication is a prime example of this. Cloud computing, which is now becoming mainstream at a very rapid pace, is perhaps the next evolutionary stage in computing for the masses. Cloud computing is a term that is increasingly being used to describe the evolution of computer resources delivery from dedicated discrete devices to shared, centrally located clusters. The cloud in cloud computing refers to a centrally available network and is typically a reference to the internet, although it is possible to deliver cloud computing on a private network as well. For example, an organization may wish to run such a system internally on a private network for its own specific use. In cloud computing, instead of installing and running applications on PCs, applications are made available from a central point on the internet, typically using web-based technologies. The applications themselves are hosted on infrastructure that is especially designed to handle the requirements of users who could be dispersed across a city, a country, or even across the world. As hardware technology improves and connectivity costs decline, cloud computing is becoming more and more attractive as an alternative to traditional computing. For mobile users, the greatest advantage is being able to access their usual suite of applications from wherever they are. Often this also means being able to access these applications from smaller mobile devices, for example palm-top computers and smartphones, rather than laptops. There are cost benefits at the corporate level as well. Hardware infrastructure can be located in areas with lower costs. For example, cost for premises, cost for utility in terms of power and connectivity. And these of course are the primary motivators in this instance. A larger pool of users share system resources, maximizing utilization, and management tasks are made easier with upgrades and updates delivered centrally. As is often the case with the technology world, innovation has not stopped at delivering applications from the cloud. Now, companies are working on delivering complete web-based operating systems, designed to work much like a computer within the cloud. These internet browser-based systems provide users with the look and basic functionality of a local computer contained within a web browser. This could very well help bring computing to those who cannot afford a PC. There are two examples of this that we can have a look at. One is a site called desktop2.com. As well as another called zimdesk.com. The way that these have evolved is actually quite amazing. We have a significant amount of resources and facilities available on these new systems. And in effect, pretty much all resources that would normally be available on a computer are actually now available within a browser window. We will now look at the digital divide. The digital divide is often used to discuss the impact and status of the information age. Now, how do you actually define the digital divide? It's not an easy task. If we look at the OECD's definition of the digital divide, they say the term digital divide refers to the gap between individuals, households, businesses, and geographic areas at different socioeconomic levels with regard to both the opportunities to access information and communication technologies and to the use of the internet for a wide variety of activities. The digital divide reflects various differences among and within countries. So it's not just a matter of having a comparison between two countries, but the digital divide can also exist within a country where, for instance, in an urban area you may have an advanced level of digital use and services, but in rural areas you may have a very different scenario where there will be very limited use, very limited resources, very limited infrastructure, and so on. ICT is an important tool for any economy. That's a given fact. The issue is that not all economies have maximized the opportunities available to them, be it for improving processes within, for example, running government machinery, or as a revenue generator to earn exports and income for their population. If we look at India as an example, in India, the ICT software and service export business is expected to generate revenues of some US $75 billion by 2010. Now that's a lot of money and a significant income for not only the country itself, but for the people who work in that industry. The key point here is that economists do not only need to use ICTs, but government must ensure that ICT is available to all sectors of the economy, not just to selected sectors. Now, how can government ensure that ICT is available to all sectors of the economy? Well, first and foremost, there must be investment in ICT infrastructure. Together with investment in ICT infrastructure, it is equally important to invest in capacity building. Now, the capacity building can take many forms. It can be technical capacity so that people can actually run and operate infrastructure. At the same time, there needs to be some understanding of the policy issues around such capacity building as well as ICT infrastructure initiatives, so that, you know, whatever policy decisions are made, they are done so in a very coherent policy environment that fosters innovation and growth. If we then say, okay, so we know what the digital divide is, but how do we actually measure it? What are the indicators? Now, typically digital divide indicators are based around a person's access to ICTs in an economy. Now, these can take many forms, and very broadly speaking, fall into one of the following. They can be access infrastructure indicators, for example, computers, and other devices that potentially provide access, for example, mobile phones, televisions, and community access centers or telecenters, as they're often referred to. It can include communications infrastructure indicators, for example, internet bandwidth, coverage of mobile phones, telephones, is there broadband available and how much of it is available to the population. A very common indicator that's been often used is the number of telephone lines per 100 people in a particular region, or teledensity as it's called. We can look at household income and whether there is capacity to purchase and subscribe to ICTs, because that's a very important factor. If people cannot afford ICTs, you cannot really expect them to fully utilize ICTs. We can look at ICT curriculum in education in particular. When do we start teaching our children about ICT, and what exactly do we teach them about ICT? We can look at gender and minority communities' use of ICT. Is there mainstreaming of gender and minority issues when it comes to using ICTs? Are we providing sufficient access to people with special needs? And then, of course, we can look at government policies towards enabling access. For example, e-government initiatives. We can look at competition and regulatory frameworks. We can look at the tariff structure. You know, how are things priced? Are they affordable? What is being done to review the tariff structure on a regular basis? Just on this point, I'd just like to highlight that, you know, it's very important that if a government is to promote ICTs, then it itself must make use of ICTs. And moving towards an e-government framework is a very important step in that direction, where you are able to provide a whole range of services to the population through electronic means. Of course, it goes without saying that you also need to be able to provide a means of access for people to access that information should you do put it online. This little graphic here shows teledensity, and it's been sourced from the ITU. What it shows is the information is slightly outdated. It stretches from 1994 to 2006, but nevertheless, it does give us some idea of how things are around the world. You will see that Europe and the CIS states in particular are very well catered for, as are the Americas. However, Africa and the Asia-Pacific region do suffer from a lack of teledensity, or it's got a very lower teledensity score. However, there's a bit of a caveat here, because we do know that the Asia-Pacific has the largest population base in the world. So obviously, the more or the larger the population base and the lower the socioeconomic spending capabilities, we do expect the teledensity to be lower. But nevertheless, it does indicate that there is a vast difference between, let's say, Europe and Africa, or Europe and the Asia-Pacific region. Now, one of the issues that has, or one of the issues that's been very prevalent when measuring the digital divide, and when we look at digital divide indicators, is that there is no real uniformity of data across regions and countries. To address this need, the Partnership on Measuring ICT for Development was created, and it is a multi-stakeholder initiative with partners that include the OECD, the ITU, UNCTAD, and the UN regional commissions together with the World Bank. And the idea here is to improve the availability and quality of ICT data and indicators, and there's a particular focus on developing countries, which are, of course, the areas of greatest need. Now, a list of core indicators has been developed that could be collected by countries to provide a very global and uniform set of statistics on the information society. Very broadly, these indicators cover 4 areas, which includes ICT infrastructure and access, access to and the use of ICT by households and individuals, the use of ICT by business, and the ICT sector and trade in ICT goods in an economy. We will just look at one of these set of indicators for our purposes. Most of this module, you will realize, is around ICT infrastructure and access issues. So let's look at that set of indicators that has been put together by this group. They have a basic core of indicators, which number 10, and then there's an extended core. So if we run through the list very quickly, the basic core includes things like fixed telephone lines per 100 inhabitants, mobile cellular subscribers per 100 inhabitants, computers per 100 inhabitants, internet subscribers per 100 inhabitants, broadband internet subscribers per 100 inhabitants, which is probably an important statistic to look at now, because as we slowly but surely move towards the broadband era, we really need to know how many people actually have access to broadband, because a lot of the new applications and technologies that are coming about do actually need broadband type services rather than dial-up type services. Another interesting indicator that's being looked at is the international internet bandwidth per inhabitant, but obviously this could be skewed in some circumstances where a country's population is very large. The percentage of population covered by mobile cellular telephony. As we all know, the developing world has had a very rapid uptake of mobile cellular technology, so this again is an interesting statistic to look at to see how well the coverage is. The next two, from my perspective, give you a real idea of where an economy stands in terms of its internet access tariffs. So here we look at how much does internet access cost based on basically 20 hours per month in US dollars as a uniform currency. And then we look at that tariff as a percentage of per capita income, which is also a very interesting way to, interesting perspective on this statistic. We look at mobile cellular tariffs, and we segment that as 100 minutes of use per month, which is perhaps a typical or average use that we would perhaps expect. And again, we look at this as a percentage of per capita income. The last indicator in the basic core looks at the percentage of localities with public internet access centers by number of inhabitants. Now we must realize that a lot of economies don't have a population base that may actually be able to afford ICTs as we know it. For example, not every house may be able to have a computer and suitable internet access. Now even if they could afford the computer and internet access, perhaps there is not a regular electricity supply, which will actually which one needs to ensure that they have continuous access to the internet and to ICTs in general. So this last statistic out of the basic core looks at how many public internet access centers are available, because often it's the case where if a person can't afford a machine, at least they'll be able to go to a center and use computers and other ICT equipment in that manner. Extending these 10 basic set of indicators are two more sets of statistics. One is radio sets per 100 inhabitants, and the other is television sets per 100 inhabitants. In some parts of the world, broadcast radio is still a very important medium to communicate. Particularly if we look at the Pacific Islands region in particular, we often say that radio is still king in the Pacific because a large part of the population still relies on broadcast radio as a means to get the latest news and to even learn of socially oriented programs, for example, on health and sanitation issues. The television sets per 100 inhabitants, again, television can be a very good medium, particularly for learning. And it's also good to look at this statistic and then compare it against the other set of indicators to see where exactly an economy stands. But it's not just looking at television sets and radio sets. I guess we also need to look at what content is being provided by the radio stations and the television stations, because if the content is not right, then just having the set doesn't mean much at all. So the indicators are good, but of course we also need to look at what actual content is being provided. Now let us look at access to ICT. Now, what is access to ICT? Now, this probably means different things to different people. So the question I would ask you is, have a bit of a think. What does access to ICT mean to you? Here is one opinion on what is access to ICT. And we call it the access to ICT hierarchy. And as I said, it's just one opinion, and it's something for you to perhaps consider. Now, to get access to ICT, we need access to a few other things first. If we start right at the bottom of this graphic, first we need access to financial resources, because obviously you need money to be able to buy and afford services. Now, if you have the money, then you need access to computing skills in education, because you need to be able to know how to use a computer. And you need to perhaps be able to read and write, because you need to read and write in order to be able to communicate effectively. Then you need access to some sort of power source of electricity, because now if you have the money and you have the necessary education and computing skills, you actually need power before you can power up a device. So let's say we've sorted that out. We have money, we have some basic computing skills, and we have a suitable electricity supply. What comes next? Well, we need a computing device, because without a computing device, we can't actually access what's available online. Once we have sorted out our computing device, we need access to sufficient, reliable, and appropriate internet provision infrastructure. Once the infrastructure is in place or it's accessible, we need actual access to the internet itself, because that's where we will go to find our content. Once we have access to the internet, we need access to content. Now, the content can take many forms. It may be news sites, it may be education sites, it may be community networking sites, and so on. Now, usually when we say, okay, we have access to the internet, we have sufficient infrastructure and all that lies beneath it, fine, we're okay. However, in parts of the world, we need to have localized content. English predominantly at this stage is the language of the internet. However, a lot of people in various regions of the world can't actually read or write in English. They may have other local languages that they are more familiar with. So it's very important that once we have sorted out all the requirements to ensure we have access to the internet, that local content is also available, so that we may put it to good use. So with that graphic, we saw that there are many potential components to access to ICTs, and each of it actually has its own challenges. Now, if we look at it, in a big picture sort of a manner, technology is really an issue. Technical solutions are always available in some way or form. However, but it does cost money. Usually, there's a school of thought that says that the issue is more policy related, and in particular being able to create a policy environment that is conducive to alleviating access issues, and one that is actually progressive. Now here the word political will comes into play. Now let's look at access to ICT technology in a very holistic sort of way. So let's look at an example. So consider this. We have a very typical rural setting which has no access to the internet. It has no electricity. The only way to currently communicate with the outside world is through the use of an aging radio telephone service, or a HF radio service perhaps, you're more familiar with that term. So the question is, how do we bring access to ICT to this community? So let's recap that again. A typical rural setting, no access to the internet, there's no electricity. The only way to communicate to the outside world is through a radio telephone service. However, we have a community that really wants to get online. They want to see, look and feel even what's available on the internet. They want to communicate with others. Perhaps they have family and friends that they would like to communicate with. So what do we do? Now, assuming that at this moment in time cost is not an issue, what can technology provide us with? Well, let's see now. We can set up satellite-based internet access for that community. Now, how do we do that? We install a satellite ground station to provide two-way communications via the internet to the outside world. Now, once we have a means to access the outside world, in other words, a satellite-based internet access system, we need to provide some sort of local connectivity so that the locals within the village setting are able to access this. How do we do that? Perhaps the cheapest and quickest way to do it is to install a Wi-Fi based local area network covering the villages and its immediate surroundings. Fine, so now we have internet access to the outside and connectivity to the outside world. We have a local network which people can access. We need to have a power source to power all this up. What do we do there? We install a solar-based power system with an appropriate amount of batteries to ensure that the system can run in times of bad weather and so on, or if something breaks down. Okay, so we have power, we have local network access, and we have connectivity to the outside world. What do we do next? Well, we need telephony. One of the reasons people want technology is to be able to talk to other people. How could we do this? Well, we could install a voice over IP system, and we could make it available village-wide through the Wi-Fi system itself that we installed earlier. We could hand out portable Wi-Fi phones that could be used for mobility, and we could provide a fixed telephone system as well. Now, most people are probably more familiar with the typical telephone. It's got a handset, it's got a bunch of numbers on it that you press, you lift the handset, punch a few numbers and you make a call. So familiarity is very important. So the portable Wi-Fi phones are fine. Perhaps some people might like that, but others would probably prefer the traditional type of telephone set that they may have seen when they've traveled elsewhere. How could we do this? We could install a voice over IP to analog telephone adapter, and this could be attached to a standard telephone, and that could be provided to every house in the village, so that every house is familiar with what it is, and it looks and feels like what they've seen perhaps in pictures or when they've traveled elsewhere. Now that we have sorted out the access part of the equation, so we have access to the outside world, we have access to a network locally, we have access to an appropriate telephony device, we need to actually have some sort of local content, because you need to give people a reason to use what's available to them. So how could we do this? We could install a local file and web server for the village. But just installing the machine doesn't mean much. We need to encourage the villagers to learn a bit of computing skills and to contribute to the content on the server. And in this way, they could actually end up developing a local information resource. Now, what form can this information resource take? For example, it can be local agricultural data, when to plant, when to sow, when to harvest. When is it good to go out fishing, when is it not, if they happen to be living by the sea. Weather information, perhaps they could start collecting statistics on what the weather patterns are. They could set up a community blog or community events list, what's happening, where is it happening, why is it happening, is it free, can you come, who cannot come, and so on. Additionally, the server system could provide a locally stored copy of regularly accessed files and applications so that external internet bandwidth use is also minimized. Now, for example, if people need the latest version of a web browser, one could set up a file sharing system on this system itself, where perhaps the administrator of the system would on a regular basis check for updates on commonly used software and store a copy of it locally, so that the community's offshore internet connection is not used to be continually dragging out files to each and every machine, so it can be all centrally stored and save bandwidth in that manner. Now, obviously, we need to have a computing device given out to each house, and the idea here is to provide a low-power computing device to every house. As an example, there are a variety of low-cost laptops being made now, which stretch in price from about $200 US to perhaps about $500 or $600 US. And you don't really need to provide a very expensive high-end product here. It can be one of the low-end laptops. Now, some examples of these are the One Laptop Per Child initiative, OLPCs as they're called. Intel's Classmate. ASUS has the EPC range, which is a pretty broad range of low-power and low-cost computing devices, which are actually very well featured. And there are many others of this variety which are now coming into the market, made by most of the major vendors now, in fact. Now, once you've sorted out all this technology part of the equation, we really also need to provide some community training. And these training sessions need to be provided to the old and young alike, so that they are able to maximize the opportunities that technology provides them with. So, with that example, we've had a look at, the fact is that technology is not really a problem. Most times, or many, in fact, a majority of the time, technology is not the problem. Yes, cost may be an issue. It will cost money to do all this, but technology can provide us with a solution. However, we need to have a suitable environment in place, in particular suitable policy environment in place that ensures that this sort of technology can be delivered to the communities when and where needed. Now, one question that is often asked and debated and discussed is, can mobile phones help bridge the digital divide? Well, let's look at some very, very basic facts that indicate that yes, mobile phones are a potentially appropriate access device. 1. Mobile phones are cheap. Some models are now retailing for less than $40. In fact, very recently I read that there is now a phone available for around the US $25 mark. Number 2, mobile phones have generally long battery life. Now, this is a very important factor, because if you are in a setting or an environment where electricity is not readily available, you need to be able to run the device for an extended period of time. And mobile phones are generally very well suited to this, because you can run, in some instances, there are mobile phones available which will run for 15-20 days quite easily, provided they have an appropriate limited amount of usage. The core infrastructure to support mobile phone services are generally already in existence, and they cover most of the populated areas. We said earlier that developing countries have some of the highest take-up rates for mobile phones, and these are being primarily used as a means to make voice calls, and they are often replacing hard-to-access landlines. If you look at the cost of deploying landlines as opposed to deploying wireless technology, you will see that wireless technology is far, far cheaper because of its broadcast nature, where one hub or node or base station can reach a large subscriber base around it. Now, if you try to provision the same using landlines or copper cables, there's a substantial amount of cost that's involved with installing cable. Conduits have to be placed, ditches have to be dug, people have to pull the cable, terminate the cable, necessary equipment has to be installed at both ends of the cable to run the service. Whereas when we look at wireless, we drop in a hub or a base station, we power it up, configure it as required, and suddenly all around that base station there is coverage straight away. So it's just a matter of someone having a suitable access device and being able to access that wireless system. If we look at most current and recent mobile phones, they have a web browser of some sort built into them. They have SMS or MMS, multimedia messaging services available. Some of these phones are now, of course, moving towards being converged devices, which means, for perhaps, let's say, for the developing world community, they may include an FM radio, perhaps even a flashlight. We are also seeing that there are various information services available over mobile services now, as are websites which support access by mobile phones. So because of the nature of mobile phone devices, where the screen size is very small, to access websites through that phone, you really need to have a specially formatted website which will actually match what's available in terms of the screen size on your mobile phone. Now, this in itself is becoming a business opportunity in many countries, where businesses are being set up primarily to support content for mobile phones. One important fact to note is that in the old days, well, I say old days, but perhaps it's even too true today. If you wanted to go and get a telephone service, you had to go fill in a form so that you apply for the service. The phone company would look at your application and decide, yes, okay, fine, yes, you can get this service, we have lines available and so on. But before you actually got the service provisioned, you would actually have to give them some money first as a deposit, so that they can safeguard, just in case if you don't pay on time or if you decide not to pay them, they can recover their costs in that manner. Now, in the developing world in particular, and even in the developed world, prepaid mobile phone services have done away with the need for deposits and credit checks. So as long as you can afford buying the SIM pack, for example, or the basic subscription service pack, which is usually priced quite low, you can get connected to the mobile phone service. Now, this of course provides a very good opportunity for a low-income earner to connect as well, so it's not limited to being able to afford. It doesn't cost much to obtain a mobile phone in most economies these days. In a community type setting, a person or a group of persons may easily be able to set up a telecenter type scenario using mobile phones to offer services for a very nominal fee. Now, here again is a business opportunity. So let's say if we look at a rural setting perhaps, where there may not be sufficient revenue streams for people to be able to afford, where everyone can afford a mobile phone. But what can happen, of course, is that there could be an entrepreneur or two in the village who will say, yeah, okay, fine, not everyone can afford a mobile phone, so let me buy a mobile phone and let me offer services through that mobile phone for a nominal rate to my fellow villagers. So, a business opportunity. Commercial transactions via mobile phones are also becoming available now in many markets. Now, these are, you could call them mobile banking. Some people refer to them as nano finance type settings. Now, apart from the efficiency and the quick access to information that having a mobile phone enables, it also at the same time offers a business opportunity to support these nano finance based transactions. In this context, when we talk about nano finance, we refer to low value transactions, which may be for, let's say, the purchase of small items at a grocery store, for example, to pay another person electronically, so you transfer credits from one phone to another phone, or from one number to another number. It could be transferring credits to your customers, or even to a friend if you need to lend them money, perhaps. So there are some nano finance opportunities available in that regard. So let's look at that question again. Can mobile phones help bridge the digital divide? Well, the short answer is yes, it can. However, a bit of help is needed. First and foremost, there needs to be an appropriate regulatory environment in place so that the mobile phone services that exist can actually evolve and adapt to market demand. There's no point in having mobile services available if people can't actually afford them. So whatever services are available, they should really be available in such a manner that a large part of the community can actually have access to them. And primarily that has to do with cost as well as, of course, coverage issues. Now, talking about cost, the service fee structure needs to be such that it encourages wider effective use, including use by low-income earners and economically disadvantaged communities. And from the operator perspective, the more users you have, the more likely are you to generate more revenue out of that network. So there is also incentive for the operator to have a larger subscriber base. And of course, every mobile phone operator would want a larger consumer subscriber base for their service. So again, yes, mobile phones can help bridge the digital divide. They are an important tool. They are potentially a very important tool. And we need to look at ways into how we can, provide some sort of environment where this can actually take place. And in some parts of the world, this is already happening. For example, in Africa and in parts of South Asia and Southeast Asia. Now, one thing, we touched on this a little bit earlier. We talked about a converged device or convergence. So, what is convergence? Well, telecommunications has evolved at a very, very rapid pace. If you look at, from the invention of the basic telephone in 1875 to today's very highly converged smartphones, these smartphones are really, really smart. That's why they're called smartphones, because they allow internet access and much, much more. And indeed, the transformation that has been brought about by all this has been truly remarkable. So what is convergence? Well, convergence refers to the evolution of electronic devices from being single-purpose, single-function devices to multifunction devices. What we see is that multiple features and functions are bundled into the one device, so they don't really have to carry 3 or 4 or 5 devices separately. You cannot, have one device which combines multiple features and functions. Now, what are examples of these? Examples are what we call these smartphones, which have internet access capabilities. They have built-in cameras. It could be a still camera or a video camera. And we even have mobile phones now which have a built-in flash as well. So they're very close to becoming like a regular camera in themselves. There are music players, which are built in, be the MP3 or something else. Productivity applications are being embedded into these devices now, so you can use Word and Office-like products on your mobile phone. But it's just not phones that we're talking about when we talk about convergence. We also talk about, let's look at a multifunction printer, which most people have these days. Now, these multifunction printers combine a scanner, a printer, and a fax machine. So that is also a converged device, and that is probably a very, very good example of a converged device beyond the usual mobile type or mobile phone type devices that we look at. Now, just on this, there's an interesting fact that let me ask you a question. Do you know who the largest camera manufacturer in the world is these days? Now, usually most people would say, oh, maybe it's Nikon, maybe it's Canon, or one of the old traditional camera companies. But the fact is that the largest camera manufacturer today is Nokia, because they ship the largest number of mobile phones, and most, if not all of their mobile phones have a built-in camera in them. So for that very reason, they are now the world's largest camera manufacturer. If we look at another very famous company that was associated with the camera world called Kodak. Now, Kodak was very famous for doing what? Well, they used to make films or camera films. Obviously, with a change in environment and how the world has changed, they have also changed in what they do. They don't really make camera film anymore. They have a small production line, from what I understand, which still does some very specialized camera films, but for the large part, their whole business model has had to change and evolve, because they now need to see what the world needs, and the world doesn't need camera films anymore, because digital cameras have just completely removed that business or the product line from their business. So Kodak has had to evolve into being, I guess they're now a digital imaging company. Convergence, we talked about device convergence. So, we talked about the multifunction printer, we talked about phones which have multiple functions and features. But it's very important to realize that convergence does not exist in the network and services, convergence does not exist in devices alone. It also exists at the network and services level. For example, we have the case now where people are delivering, or providers are delivering voice, data, and video over one medium. The so-called triple play solutions, which are being made available in some economies and markets. Now, what's happening is, in the old days, you had your telephone company, you had your radio station, and you had your television station, and then perhaps you had your ISP. And, these could be 3, 4, 5 different companies that you had to deal with. Now, with the way technology has evolved, there's been a real blurring of the roles, or the traditional roles, should I say, and sectors. Because now you may have the one company which offers you your voice or your telephone, it offers you your data or your internet. It may also offer you television channels. And of course there's internet radio available now, and internet television as well. So it's basically one cable or one service provider now that is able to provision all of that for you. Now obviously this has some important policy issues which arise, because there's a real blurring of these roles. You know, is company a telecom company? Are they a television company, or are they a data company? Are they an ISP? So there is some sort of policy reform usually quite very necessary to ensure that all this takes place, and then the roles and responsibilities are understood. At the same time, it's very important to ensure that these companies are able to provide services that they are providing in a really effective and efficient manner. So the last thing you want, of course, is that yes, I have one company that provides me with everything, but it doesn't provide me with 100% quality or service level, and it's 80 here, 50% there, and 30% there, because you need to have consistency and quality of service in what's being provided to you. To round off this session, let's look at an example of a very highly converged device which is targeted at the corporate or professional user. Now this is a mobile phone, or it's actually a smartphone made by Nokia called the E61i. And you know, this is not an endorsement of the product or anything in that manner, but it's just to give you an example of what's available in this, what is effectively sold as a mobile phone, but it is much, much more than a mobile phone. So let's just have a quick look at some of its features. Now it has what we call a full QWERTY keyboard. So that's like a normal keyboard on a computer, you know, with all the keys available. It has that built in. And the layout is very similar to a keyboard layout, but obviously it's smaller because it has to fit in onto the mobile phone itself. It has a navigation joystick. It has a decent sized display, 320 by 240 pixels, which can display up to 16 million colors, you know, so which is very much similar to what a computer can do. It has a 220 megahertz processor and 64 megabytes of internal memory. So, you know, all these, you know, several years ago, you could not buy computers with that sort of resources available on them. It has an external memory slot, so you can add more memory to it, usually up to around perhaps 1 gig or 2 gigabytes, so, you know, which in itself is a lot of memory. Although, of course, with how technology is evolving, I suppose it won't be too much memory for too long. It has got a built-in Wi-Fi support. It has got Bluetooth, infrared. It can support a USB port or a USB connection. It has support for all major GSM networks, so you can pretty much use it just about anywhere in the world, with some exceptions. It has got a built-in voice over IP client, as well as a loudspeaker built into it. So you can have a two-way communication just without using a headset even. It has embedded internet applications like a web browser, an email client, instant messaging clients. It has a personal information manager, so that you can have a calendar, a to-do list, you know, alarms, reminders, the usual stuff you have for personal information management. It allows you to synchronize your data with an application like Microsoft Outlook. It has a whole host of productivity applications like a word processor, a spreadsheet, a presentation tool. You can read Acrobat PDF files on it. There's a zip file utility, so you can zip and unzip files. It has a whole lot of multimedia applications. So, you know, there's an MP3 player, there's a video player. You can stream video. There's a video recorder, so you can record calls or an event or take notes. It has a text-to-speech reader. It's got a built-in camera, which offers both still and video recording. And it can also support direct printing to a Bluetooth-enabled printer, as well as some corporate features like supporting a virtual private network, or VPN. The other interesting thing about this device is that how long it can last. It offers up to 9 hours of talk time and 17 days on standby, depending on how much you use it. So, you know, looking at all those statistics and specifications that this device offers, is not that very different from a computer itself. So I would say this is a mini computer, pretending to be a mobile phone rather than the opposite. Now, let's look at some policy considerations that come out of this session. First and foremost, there is a need to have an established and active national ICT task force which considers advances in technology in an effective manner, and it provides timely and relevant input into the overall national planning processes, because no evolution in technology at the local level, and when I say evolution of technology at the local level, what I'm referring to here is that, having sufficient access to ICTs, having the infrastructure in place. But, how do you decide what infrastructure to have? Well, you need to have some sort of body which looks at this, which makes some pertinent decisions. It debates some issues, what's needed, what's required, and when is it required. So a national ICT task force, I think, is very important, particularly in the developing country context, so that there is some direction to where ICT should head locally and nationally. There is also a need to have a national ICT strategy with balanced input from all stakeholders. Now, this is very important. We need to have a multi-stakeholder participation process, and we need to ensure that whatever strategy is implemented is in line with global technology trends and local needs as well, because you don't want to take up obsolete technology. Sometimes you have to strike a balance between the most cutting-edge technology and perhaps current technology, because issues of affordability and is it appropriate technology or is it an appropriate solution for the circumstances we are in. Now, I'd just like to talk about this multi-stakeholder thing that I mentioned again. Often people have said that in the past decisions have been made by the government or the government and the telecom operators have made a decision and they've never consulted us or me or you. So having the sort of scenario where we have a multi-stakeholder forum, where it's a room, government is there, telecom operators are there, civil society is there, the typical user is there, NGOs are there, the private sector is there, so that you can all discuss the issues that are required. You can look at options. Each can state their views, their problems, their issues, their challenges, and then some sort of consensus can be reached on what's the best way forward. So a multi-stakeholder participation process is very, very important in this regard. National statistics collections. Now, every economy collects statistics, which cover a whole range of things in how people live within a country. But these statistics collection efforts should also include an ICT aspect to aid in planning and development. Very, very important. Now, you don't, of course, have to have 50 or 60 questions on ICT, but try and identify some simple but important aspects or indicators which would give us a snapshot of what the state of the nation is or the state of the economy is when it comes to ICT aspects. We looked at those indicators before, and perhaps they're a good way to address this. Policy reform efforts should explore market liberalization and introducing competition, but should also review access cost structures and service provisioning to ensure that service providers offer the required services in a reasonable manner. Policy making should explore alternative forms of access, in particular the potential of mobile telephony and convergence. And we should look at what is appropriate technology for the circumstances we are in. As I said before, it's not a matter of installing the most or deploying the most cutting advanced technology, but we also need to balance them so that we have the right balance that is struck between what's good, what's bad, and what's actually required on the ground.